revise the previous topic that we did, the dipole moment. So firstly, what is meant by dipole? Dipole is when you have a positive charge and a negative charge with you. Both should have the same magnitude. It's just that their signs are opposite. Like you have plus q and you have minus q with you. So that forms your dipole. Dipole moment gives you the strength of the dipole, whatever is the magnitude or the strength of the dipole. So it is calculated through this formula that if you have two charges plus q coulombs and minus q coulombs with a separation 2a between them, then you say if you take any of the charges, whatever charges are present, and multiply it with whatever is the separation between them, whatever is the separation between the two charges, you multiply it with. That gives you the magnitude of the dipole. So what will be the unit of dipole moment?
Coulomb meter.
Coulomb meter, because the SI unit of charge is coulomb and the distance, SI unit of the distance is meter. So it will be coulomb meter. Yes, Hamza, you tell me what is the direction of dipole moment? And not only Hamza, till the time Hamza is responding, all of you write me in the chat box. All right, Fatima, tell.
It's negative from negative to positive.
Negative charge to the positive charge. This is the direction of dipole moment. All right. Then we had seen two cases. One was the axial line case, another one was the equatorial line case. All right. See, let us begin with electric flux today. We'll cover whatever rest electric field lines in the next class. See, for studying electric flux, you have to understand the concept of electric field lines. So just remember, electric field lines these are the pictorial representation of electric field. You already know what is meant by electric field. So see, electric field has to be represented. So if you have to represent electric field, you represent it through electric field lines. So these are basically continuous curves like this. And if you drop a tangent on it, this gives you the direction of electric field. So these continuous curves, these are known as electric field lines. So electric field lines have certain properties associated with them. So let's not go into the details of the properties of electric field lines. The basic definition of electric field line is this only, that these are continuous curves which represent the electric field. So basically pictorial representation of electric field. And the tangent to it gives you the direction of the electric field. Regarding electric flux now, let us begin with electric flux. We'll discuss all the properties of electric field lines. We'll discuss in detail. See, if you have a surface with you, let's say this is a surface. If you have a plane surface with you, and if I tell you there are 4 electric field lines passing through it. All right, these are 4 electric field lines. We can count them. This is 1, this is 2nd, this is the 3rd one, and this is the 4th one. So we have 4 electric field lines passing through it. Now see what happens. Electric flux is basically all the electric field lines which is crossing an area normally. Normally means what? Perpendicularly. If all these electric field lines, these are making an angle of 90 degree with the plane surface. See, this is one electric field line. This is making an angle of 90 degree with this plane surface. These are all the electric field lines which are making 90 degree. Normally means 90 degree. So all the number of electric field lines which are crossing this area normally, that is known as electric flux. So how many lines are crossing this area normally?
4.
4. So electric flux will be 4. This is the representation of electric flux. We represent it through the symbol phi. So phi is a 4. So what is meant by this is that 4 electric field lines are crossing the surface area perpendicularly or normally. So let me write down the definition only of electric field line. So number of electric field lines is this audible now?
Yes, ma'am.
Yes, ma'am.
All right. So was my voice clear when I was speaking right now, or did it stop?
It was clear.
It was clear,
It's
ma'am.
All right. Now see, so electric flux is basically what? It is the number of electric field lines which is crossing an area normally. So what is meant by normally?
90 degree from the surface.
90 degrees from the surface, that is perpendicular. This is what is the definition of electric flux. So whatever number of electric field lines you have which is crossing the area, that makes your electric flux. Now see, now the mathematical part, how do you calculate it? If this is the surface area, let's say this is some plane surface area S. This is a plane surface. This is a plane surface. And electric field lines are passing in this manner. This is the direction of electric field. It is making some angle over here. Let's say it is making an angle theta. So will this electric field line be considered under electric flux?
No,
Why? Reason, Fatima?
because it's not perpendicular to the surface.
It's not perpendicular to the surface. So we require that electric field line which is perpendicular to the surface. So this, if I take this direction, this n cap, this is making an angle of 90 degree. This is a unit vector that I have taken n cap. So can this be considered now, this electric field line?
Yes.
Yes, ma'am.
So see, this is the direction of the area vector. This n cap which I have written, this is basically the direction. This is the direction of the area vector. So this angle theta that we take, this angle theta, this is the angle between the electric field lines and the normal to the surface. This angle theta is not the angle with the plane surface. This theta is the angle between the electric field line and the normal. It is not making an angle theta with the plane surface. No, had it been making the angle theta with the plane surface, then it would have been in this manner, electric field line with this theta. This would have been the angle. But this theta is the angle between the electric field line which it is making with the perpendicular to the surface. And this perpendicular to the surface is known as area vector. This is known as area vector. So area vector gives us the direction of electric field. All right, which is perpendicular to it. This is perpendicular to it. Then the formula of electric flux you have. S is what? S is the surface area. S is the surface area with you. So formula of electric flux is dot product of the electric field. This is the electric field and the surface area that you have. So how do you open dot product?
Crossing.
Crossing. Anyone else?
We put theta, like cos theta, sin theta.
Cos theta, sin theta, both?
No, yeah, in this case, maybe sin theta.
Anyone else? Cross product. See, you have two types of products values with you. No, one you have as the cross product, other one you have as the dot product. Nobody remembers dot product and cross product now. Yes, Akshay, do you want to try?
Vector A into vector B sin theta, something like that.
Yes, vector into vector, that gives you sin theta product. So
Ma'am, I
there
joined
we will,
late, so which part are you teaching now?
this is electric field and charges from your unit first. You in your
Oh,
unit first, electrostatics, you have two chapters. One is electric field and charges, other one is potential and capacitance. So many new students are there. No, Akshay is new. Somebody else has also joined today. Sayyida Rufia, you're also new to this. Your first class.
Yes, ma'am.
All right. So we had started with electric field and charges. Now we are in the middle part of the chapter, almost towards the end. So we have discussed electric field. So let me tell you just in brief what is meant by electric field. If you have a charge with you, that charge will be having certain field around itself in which electrical properties or electrical phenomena can be experienced. In electric phenomena basically means forces, electric force, electric field. So in that particular area, that confined space, that space where electrical properties can be experienced, that is known as electric field. So now we have reached electric flux. So number of electric field lines which are passing through an area perpendicularly or normally, this is known as electric flux. See, how do you open dot product? You take the magnitude of the first quantity, you take the magnitude of the second quantity, and you put cos theta over here. When you take the cross product, in case of cross product, you take the magnitude of the first, take the magnitude of second, multiply it with sin theta in case of cross product. So is it clear, Fatima, Zaid, and all of you?
Yes, ma'am.
All right. So in case of dot product, you take the magnitude of the first vector, you take the magnitude of second vector, and multiply all the quantity with cos theta. Now here theta is important because theta, you might be getting theta in terms of the plane. As in, you might get this theta as 120 degrees, or you can get this theta as 60 degrees. You are not concerned with this theta. Which angle are you concerned with? The angle between the electric field line with which it is making with the area vector. So I'm specifying it. Theta is the angle between electric field and the area vector. Area vector basically means the direction of electric field. Area vector is the vector quantity which is perpendicular to the field, because many a times electric field is not given perpendicular to the surface. So we consider the area vector. If this is your plane surface, perpendicular to the surface, just in this manner, this is your area vector. Just drop a perpendicular to the surface. That gives you area vector. All right. So there is no need of direction in case of electric flux because this is a scalar quantity. Electric flux is a scalar quantity. This is a scalar quantity. So you just take out the direction using this formula. Now, all of you know the SI unit of electric field. All of you know the SI unit of this surface area. What should be the SI unit of electric flux? Yes, SI unit of electric field. First, tell me what is the SI unit of electric field? Yes, Akifa, you tell me what is the SI unit of electric field?
Newton per coulomb.
Newton per coulomb. See, electric fields relation we have also seen as electric field was what? Electric field was force per unit charge. We can also define electric field as the force experienced by a unit positive test charge. So electric field's SI unit is what? Newton per coulomb. So this is Newton per coulomb for electric field. Multiplied with what? What is the SI unit of surface area? Yes, Ed. What is the
Ma'am, meter
SI?
square?
Meter square. No. For distance, it is meter. And in case of surface area, you multiply length with length. So you get meter square. So you have meter square over here. So your SI unit becomes Newton per coulomb meter square. Or you can write it in this manner. You can write it in this manner: Newton coulomb inverse meter square or Newton meter square per coulomb. One more SI unit is there, that SI unit of electric field is also volt per meter. So it can also be volt meter per meter square. This becomes per meter square. So which can be written as voltmeter. This is also one. All right. So just copy it down. Done?
Yes, teacher.
Yes, ma'am.
So see, if you take a plane surface with you and you drop n number of perpendiculars like this. So see, all of them will be perpendicular to the surface. So every line, every area vector will give you the direction. So you don't have a single direction in case of area vector. Any perpendicular to it, be it here or be it over here. The condition is that these field lines, this area vector should be perpendicular to the surface. So this gives you the direction of area vector. So area vector does not need to be on the center of the plane surface. It can be anywhere. The condition is that area vector has to be perpendicular. So you can take it at the edge, you can take it anywhere. It's just that it should be perpendicular. You are just concerned with this 90 degree. So direction of the area vector. This is perpendicular for a plane surface. This I'm talking about a plane surface. For a plane surface, this is same at every point. This is same at every point. So this was regarding a plane surface. You can have different kinds of surfaces. You can have a curved surface with you. So what if you have a curved surface? There also this everything is same. Means all the rules and that we have studied are applicable to the curved surface. So if you take a curved surface, let's say this is a curved surface, and various electric field lines are passing through this surface. These are the electric field lines which are crossing this surface. So again, this electric field line is not normal to the curved surface. What do we have to consider? We have to consider area vector. So if I draw a perpendicular to this in this manner, this is making an angle of 90 degree. If the electric field line makes an angle of 90 degree, then you are not required to calculate this or take out the area vector, because electric field line and the angle between electric field line and the area vector will be 0. And what is cos 0 degree? It's 1. So you will get the same answer only, even if you take an area vector or not in case of perpendicular electric field lines. But in this case, this is making some angle theta with the area vector. It wasn't making angle of 90 degree with the curved surface. So you take area vectors at all the points like this. This is the area vector making angle of 90 degree with the surface and angle theta. And this is the electric field line. Now everything is same. You have to apply electric flux over here also. You have electric field with you, you have area vector with you, and it must be having some surface area. So let's do one thing. Let's say this is some curved surface. All your curved surface in areas include your spheres, your cylinder. See, cylinder has 3 surfaces, upper 2 flat surfaces with a curved surface. So cylinder also gets included. Cylindrical surface. This is the surface of cylinder or hemisphere. In fact, you can consider cone as well. See, if you talk about cone, cone has a curved surface, curved flat surface, and it has a curved surface as well. So cone will also come under the curved surfaces. So what you can do, if you have such a huge surface area, you can take a very small surface area. Let's take this much surface area. This is a very small surface area, ds. So consider a small surface area element, that is ds. ds is a very small surface. So if you have variable electric fields with you, or you have a curved surface with you, then your formula will be same. d phi will be now, instead of phi, you will have a small segment, because we have considered a very small segment ds. So electric flux will be d phi will be equal to electric field dot ds. Instead of taking s and instead of taking phi, you take the surface integral, that is E dot ds. So the net flux through the system system, this becomes integral of E dot ds. When is this applicable? When do we take integration of electric field dot ds? When this is variable, surface area is a closed surface area. All right, this is a curved surface area. So you take E dot ds. So this is basically surface integral. This is surface integral. So when do we consider the surface integral? When we have closed surfaces. For closed surfaces include your sphere, cone, hemisphere, cylindrical surface, all the curved part of the cylindrical surface. You can write this in this manner also. E dot ds with this sign. This shows that you have the closed surface area, and this is one of the condition as well. This simplifies you, this signifies you that this is a closed surface area. So this is basically closed integral of E dot ds. This signifies the closed surface. If you have a curved surface with you, curved surfaces means sphere, hemisphere, cone, cylinder, then you use integral, closed integral or surface integral of E dot ds. Now here we'll be practicing questions. Everything will be same the way you have done your integration. All right, so just note this down as well for curved surface and the direction of area vector. Then we'll do questions on this. Just note down this question. We'll solve it together, and if anybody gets the answer, can send me. First, note it down. Let's discuss it now. See, electric field is given you as 10 Newton per coulomb. This exists in space. You have to calculate flux through an area of 5 meters square in XY plane. So in the XY plane, let's say this is the XY plane. This is your x-axis, this is your y-axis. All right, so in this XY plane, you have a surface area with you, and the area is 5 not centimeters, it is 5 meters square only. All right, and you have electric field with you as 10 Newton per coulomb. So electric field lines are inclined, angle is not mentioned, just mention the angle, are inclined at 60 degrees with the plane of the area. Just add this. Without this, you won't get the answer. Electric field lines are inclined at 60 degree with the plane. Plane means if this is your electric field, then the angle that it is making with the plane, this angle, this is 60 degrees. And you have to calculate the flux. Just add the 60 degrees. Yes, Josefa, what is the formula of flux? Yes, Josefa Ahmed. All right, Fatima, what is the formula of electric flux?
E times A times cos theta, where
Flux
A is
EA cos theta. EA cos theta, which is simply dot product of E and S. This is the dot product of E dot A. S or A, I have written A. A denotes the surface area. S was the surface area over there.
I studied it with A in school.
All right, all right. It doesn't matter. Be it A or S, it has to be electric field multiplied with the surface area. So you can consider it A, you can take it surface area S or also. Yes, Josefa, you didn't answer. This is the formula. Now is it clear, Josefa? All right. Okay, Huzaifar. Yes, Hamza Shekhani, you tell me what is the electric field given in this formula? What should I put? All the values. What is electric field given? Yes, Hamza. What is the electric field given? Which value should I put? E instead of
10 raised to n.
What should I put?
10 Newton per coulomb.
Per coulomb. Correct. 10 Newton. This is the electric field given. So it should be 10. Hamza, you only tell me what is the area that I should put?
Area is 5 meters square.
5 meters square. So this will be multiplied by 5. And Hamza, complete this cos. What is the angle that I should put?
Angle of 60 degrees.
60 degrees.
50 cos 60.
Cos 60 degree. All right. Anyone would like to correct him? Or we should put cos theta as 60 degrees?
Ma'am, we should keep 30 degrees. Sir.
We should keep 30 degree. Yes, Krishna. See, we have to, Hamza, remember, whenever you are solving this question regarding electric flux, you don't have to consider electric field with the angle that it is making with the plane. It has said in the question that if field lines are inclined at 60 degree with the plane of the area, means this angle is 60 degrees. If this is your plane surface with you and this is your electric field, then this angle is given to you as 60 degrees. You are not required to calculate and use this angle. First, you have to take the perpendicular to it. This is what? This is the area vector that I was talking about. Then you have to consider the angle between the area vector and the electric field. This is the theta that is used in this formula, EA cos theta. This is the theta formula that is you required to use. You don't have to consider this angle. You have to consider the angle between the electric field and this area vector, n cap. So if this hole is 90 degrees and this part will be what? This will be only 30 degrees because see, normal, this is making an angle of 90 degree. Electric field lines, these are making an angle of 60 degree. So what is left? What is the angle left between electric field and normal? This is 30 degrees. Then only 60 degrees plus 30 degree will give you 90 degree. Is this clear to all of you? Why are we considering 30 degree instead of 60 degree?
Yes, ma'am.
Yes, ma'am.
All right. So it will be cos 60 degrees. Instead of 60 degrees, we'll have cos 30 degrees. Is this clear? Usage of formula?
Yes, ma'am.
So this is 50. This will be root 3 divided by 2. So you get 25 and root 3 is left. And the unit is Newton, Coulomb inverse, meter square. Just note down the solution. We'll do more questions on this. So it says that you have electric field with you. Electric field is given as I cap plus 2 J cap plus 3 K cap Newton per coulomb. And the surface area is given to you as I cap minus J cap plus K cap meter square. So you have to calculate the surface area. So whenever you don't have any angle in such a questions, you have to consider that electric field is normal to the surface. That's why it is not giving you any angle with the plane or the area vector. It means electric field is perpendicular to the surface. Now see, the formula of electric flux is what? It is E dot S. Dot product we have to take. Electric field's value is this. This is the value of electric field. I cap plus 2J cap plus 3K cap. This is E dot what? S. S is the surface area, which is I cap minus J cap plus K cap. This is the dot product that you have to take. So yes, how do we solve the dot product is that take the coefficient of the I cap unit vector with you, whatever is the coefficient of I cap given to you, and multiply it with the coefficient of I cap given in the second part. So what is the coefficient of I cap over here?
1.
1. This will be 1 multiplied by 1, which gives you what? 1. So
1.
we have 1 instead of I. Also, I cap dot I cap, J cap dot J cap, K cap
Is
dot
also
K
1.
is also 1. Exactly. I dot I, J dot J, K cap dot K cap, all this is equal to 1. So what did we do? We actually multiplied 1 I cap dot 1 I cap over here. All those who have forgotten the concept of dot product, we solve it in this manner. So 1 into 1 gave us 1, and also I cap dot I cap gave us 1. So that's why we have considered this one. Now, over here, what do we have? We have 2 J cap, and here we have minus J cap. So what do? We take the coefficient of it. We take the coefficient, so this will be 2. We take the coefficient of J cap. What is the coefficient of J cap over here?
Minus 1.
Minus 1.
Minus 1. Yes, it is minus 1. So you multiply 2 with minus 1. What do you get? Minus 2. And then J cap dot J cap will give you 1 only. So you have minus 2 left. Then 3 K cap multiplied by, what is the coefficient of K cap over here?
1.
1.
1. So 3 into 1 gives you 3 only. I'm repeating. See, coefficient of I cap is 1. Coefficient of I cap is 1. Multiply both the quantities. 1 into 1 gives you 1. So we had written this one. Take the coefficient of J cap now. 2 multiplied by minus 1. 2 multiplied by minus 1 gives you what? Minus 2. So that's why we have written minus 2. Then coefficient 3 multiplied with the coefficient 1 gives you 3. So you have 1 minus 2 plus 3 gives you 2 Newton per coulomb meter square. Is this clear?
Yes, ma'am.
All right, just note it down. All those who have written this second question, note down the third question and send me the answers of third question. We have done 2 questions together. Now the third part you have to send me. So all of you try this. Electric field is given, area is given to you as 5 meters square, but just be careful about this in the XY plane. So you have to calculate area in XY plane. So don't just take 5 meters square. What will it be in case of XY plane? Just try this question once. And whoever gets the answer, send me the solution. Z, when you'll take the dot product in this manner, similar to what we have done, I cap and j cap, when all these terms will get multiplied, I dot I and k dot k, that will be 1. So you will not get the answers in terms of I cap and j cap. Just check once again. You are correct. Just try it once again.
Okay.
For the rest of you who are also trying, electric field is given, so you don't need to change electric field. Electric field is given. Regarding area is given 5 meters square. You have to see the plane. It has mentioned you XY plane. So where, in which unit vector where area lie? If you have XY plane, what will be the perpendicular to it? That unit vector you have to consider with area. Then solve it. Then see what's your answer coming. Zaid, it's correct. It's correct, Zaid. Zaid has submitted his answer first and he's correct. Just remember, you have the plane as XY plane. So we take the area vector. So if you have the XY plane, area vector will be which unit? I cap, j cap, k cap. So that will be the area vector. If you think it is I cap, then it will be 5 I cap. Area vector will be 5 I cap. Otherwise, area vector will be 5 j cap. Otherwise, it will be 5 k cap. So just think what will be the area vector multiplied with the electric field. Hamza, you are also correct. Yes, Akifa. Correct answer, Akifa. You are near to the answer. Actually, I think there must be some error. Let me help you. See, everyone, let's discuss it now. So some of you have given correct answers. 3 students have given. Okay, Hiba has also given. Hiba, Akifa, Hamza, and Zaid. All right. See, electric field is what? Electric field is I cap plus 2 J cap plus 3 K cap Newton per coulomb. So you have electric field with you. You don't need to change electric field. Regarding the area vector, what is the area that we take? It is given 5, but how do we consider it, in which plane it is? Is it 5 I cap? Nothing else is given, so we cannot take it on our own. So see, your sheet or whatever the surface area, this plane surface area, this is given in xy plane. This is xy plane. What is meant by xy plane? Xy plane means the plane between the axis of x and y. If you have this as x-axis and you have this as the y-axis, then this plane that you get, this is your xy plane. If I say this is x-axis and this is z-axis, then this plane that I'm getting, this is xz plane. If I'm saying this is this outwards axis, this is pointing to the z-axis, and this is the y-axis, then this plane is yz plane. So I have considered right now that this is the x-axis, and this is the y-axis. This is the x-axis, this is the y-axis. So this plane, this becomes xy plane. Xy planes mean the plane between the x-axis and the y-axis. This is your xy plane, this plane. Not this and not this. This is your xy plane. So if you have xy plane with you, what will be perpendicular to xy plane? X-axis, y-axis are already perpendicular to each other. What is the third axis that is perpendicular to both of them?
Z-axis.
Z-axis. And what is the unit vector of z-axis?
K cap.
K cap. All right, Akshay, just write once again. So K cap. So you have the unit vector as K cap. Why are we considering K cap? Because we need area vector. Area vector is what? Perpendicular to the surface, perpendicular to the plane. Plane is xy plane. So perpendicular to it will give you unit vector as K cap. Now you have it in term, you have the direction as well. Here we can calculate the flux the way we have been calculating. I cap plus J cap plus 3K cap. This is electric field dot S. S is what? S is 5K cap. This is S. This is 5K cap. What I've written, this is your electric field. The formula of flux is what? E dot S or E dot A, whatever is comfortable to you. So see, I cap's coefficient is 1. What is the coefficient of I cap over here?
0.
0, because there is no I cap over here. And here I cap's coefficient is 0. Basically, this means I cap plus 2J cap plus 3K cap multiplied with, means dot product of 0 I cap plus 0 J cap plus 5K cap. When it has mentioned you only 5K cap, nothing else is given. That means you have 0 I cap and 0 J cap, because other vectors are not there. That's why it has not been written. So 1 I cap multiplied by 0 I cap gives you what? 1
0.
multiplied by 0 gives you 0. Plus again 2 J cap multiplied by 0 J cap gives you
0.
0.
0. Finally, you have 3K cap multiplied by 5K cap. This gives you 15. So your flux becomes 15 voltmeter, or you can say Newton coulomb per meter square. This is your answer. This is how you get it. Clear to all of you? Is it clear, Akshay, Fatima, Hamza,
Yes, teacher.
Yes, ma'am.
Huzaifa, Sufia, not Sayyida Rufia?
Yes, ma'am.
All right. Just note it. Just write down done in the chat box when all of you have written. So done. Most of you have written it down.
Yes, teacher.
All right. So let's move forward. These were some basic questions from electric flux. Now see, before we move further, if you have different surface area with you, here I was taking a plane surface. Plane surface means your 2D, rectangular shape I was considering. You can get a different surface area if you have a sphere with you. Let's say the radius of the sphere is r, and you have considered a very small section ds, as I've told you the way we take it for the calculation of flux. Flux is what? D phi is integration of E dot ds, that I've told you. But see, what ds will you consider? Ds in case of a sphere. What is the surface area of a sphere? R is the radius, surface area of sphere. Nobody knows the surface area of a sphere. Yes, Akshay, try.
4 pi r square.
4 pi r square. It will be 4 pi r square. This will be 4 pi r square. So whatever electric field is given to you, whatever radius is given to you, put it over here, you can get the value of flux. Or if I say, if you have the curved surface area of cylinder, curved area of cylinder. So for a cylinder, if you have it, this is in such a manner that it has two flat surfaces with a curved surface in between. So radius of this is small r and length of the cylinder is this small l with you. Then you take a very small surface area with you. This is ds that we consider. So here in the ds, in this case, this will be 2 pi RL. This is the surface area of a sphere. Pi r square L is the volume. When you are considering the surface area, you have to take 2 pi RL. This is the surface area for just the curved part, curved surface area, not the total surface area. All right. So in this manner, you have various surface areas with you, and you can consider whatever is the surface area and multiply it with the electric field. See, if you have, let's do a derivation, the question form only. If charge Q is placed at the center of a sphere, and we have to calculate the flux through it. We have to calculate the flux through it. So how will we solve it? So this is your sphere. It must be having its radius. Radius is, let's say capital R is the radius. Capital R is the radius of the sphere. So see, you have to take the perpendicular to it. Let's say electric field is this. This is electric field. So what do we have to do? We have to take the area vector first. How do we take the area vector? We drop a perpendicular to the surface. So if we drop a perpendicular to the surface, this will be n cap. This will be n cap if we take. Let us take electric field as perpendicular only. Let's take electric field as perpendicular only because there is no mention of any angle over here. So let's not consider the electric field as non-perpendicular to it because nothing has been mentioned. But if it is given, then you solve it in this manner. If you are provided with any angle. Now see, phi is what? This is closed integral of E dot ds. As I've told you, n cap is also here. Electric field is also perpendicular to the surface only. So what will be cos theta now?
90 degree.
90 degrees. Angle between electric field and area vector. Check once again. 0. See, it is making angle again 90 degree with the surface. We don't have to take it with the surface. It will be 0. This will be E ds, not the vector. Now we are taking the magnitude. We have to take the magnitude and multiply. This will be E ds cos 0 degrees, closed integral. So phi will be what? Closed integral of E ds. Electric field. Fatima Munir, you tell me, what is electric field due to sphere? We have done this. We have done a very small derivation of it. Electric field due to point charges or sphere. What is the final formula that we got? Till the time Fatima Munir is replying, rest of you also reply me in the chat box. What is electric field due to a point charge or a sphere? It is same for both of them. There was a very small derivation for it. Yes, Fatima, reply. Electric field for a point charge that we have calculated.
E equals to Q
Easy.
by
Yes.
4 pi
4 pi epsilon naught
epsilon naught r square.
r square. Correct. Absolutely correct. Yes, Krishna and Akifa were also right. They have also answered. Electric field is what? Electric field for a point charge or a sphere. We have seen electric field was what? Force by charge. Force was kq multiplied by q divided by r square. So one q got eliminated. This was the formula, kq divided by r square. So we can write it in terms of epsilon naught. This becomes q by 4 pi epsilon naught r square. This is the electric field due to a point charge or a sphere. The value is same. The calculation is same. This is the electric field. So if we put it over here, electric field is this. Also, let us consider the surface area as well. ds, we have just seen if we have a sphere. Just now we have done when I've given you that note point. For a sphere, the surface area is 4 pi r square. So
4 pi
r square. Yes, correct. So see, capital R is given. Let me not write small r over here. Let me write capital R only because the separation is capital R. So let me not write small r. It will be q divided by 4 pi epsilon naught capital R square. So the surface area will be 4 pi capital R square. We have electric field with us. We have surface area with us. We just need to multiply both of them. So this will be electric field is what? Q by 4 pi epsilon naught r square. This is electric field with you. Now I'm multiplying it with the surface area. That is 4 pi capital R square. So r square gets cancelled. 4 pi gets cancelled. What are we left with? Q divided by epsilon naught. Is this the final answer? Is it clear? Yes.
Yes, ma'am.
Yes, ma'am.
Yes.
All right. So see, this result that you are getting, this is a kind of derivation for you for a law that is known as Gauss law. Understand what is the definition of Gauss law, what is the statement of Gauss's law. So Gauss's law says that if you have a system with you, the total charge enclosed in the system, let's say it is Q or whatever is the charge enclosed by the system. Electric flux was what? Electric flux was E dot ds, closed integral of E dot ds. This we have seen. This is equal to the result that we have drawn just now. This is equal to Q divided by epsilon naught. This was the answer, no? We were getting just few minutes back. This is one of the important derivations of yours. Phi is Q by epsilon naught. So Q by epsilon naught, Q is what? Q is the total charge enclosed. And all those who don't know what is meant by epsilon naught, see epsilon, this symbol, this means absolute permittivity. Absolute permittivity means how a force is dependent on a particular medium. You have a particular value of force in air. You have a particular value of two charges when they are kept in water, medium is changed, then the value of force. If the charges are kept in glass, then you have different value of force. So what governs this is this absolute permittivity. This is the absolute permittivity. So permittivity of free space means air or vacuum, that is denoted through the symbol naught, epsilon naught. This becomes absolute permittivity of air, whose value is 8.85 into, yes, someone completed, 8.85 into, nobody remembers the value of epsilon naught.
From 10 power negative 12.
10 to the power minus 12. Correct, Krishna. 10 to the power minus 12. This is the value of epsilon naught, permittivity of free space of air. So this is known as your Gauss's law. What is meant by Gauss law? See, according to Gauss law, what is this? This is the electric flux. So according to Gauss law, electric flux is, can I write it in this manner? 1 by epsilon naught multiplied by the charge enclosed. Both are same. So Gauss's law says that this is Gauss law. Gauss law states that electric flux is 1 by epsilon naught times the charge enclosed. Electric flux is what? The total charge enclosed, total flux, electric flux, through a closed surface, So first condition is satisfied in the statement as only closed surface. It has to be a closed surface. So this electric flux through a closed surface is what? This is 1 by epsilon naught times. 1 by epsilon naught times what? The total charge enclosed within the surface. If you have a charge outside which is not enclosed within this closed surface, you are not going to consider that charge. For example, 2 coulomb is kept over here, 1 coulomb is kept over here. The total charge enclosed by the system is only 2 coulombs. You cannot take 1 coulomb, neither you can take 1 coulomb nor you can take 3 coulomb. Whatever charge is enclosed within this system, that becomes your charge enclosed, Q enclosed. So electric flux is what? 1 by epsilon naught times the total charge enclosed by the surface. This is the statement of Gauss law. Whatever charge is considered within the closed system, that is the charge Q enclosed which you have to consider. No matter what, how many charges are lying outside. If not even a single charge is lying, then you simply say electric flux is 0 because no charge is residing in the surface. Q enclosed is 0, hence phi will also be 0. All right. So you have to consider all the charges which are present in the system, and the system has to be closed. Closed system will be considered. So net electric flux through the closed system, that will be 1 divided by epsilon naught multiplied by the charge enclosed. So the derivation which we have done, this part, phi is equal to Q by epsilon naught, this part, this is your Gauss law. Gauss law states that flux is 1 over 1 by epsilon naught times the charge enclosed. Is the statement clear now of Gauss law? Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
What about Hamza, Hiba, Huzefa, Zaid? Is it fine?
Yes, ma'am.
Rufia, is it getting clear to you?
Yes, ma'am.
All right. So we'll do the properties of Gauss law. First, you note these down. Done, all of you?
Yes, teacher.
All right. Let's see some of the properties of the Gauss law. Some of the properties or some of the conditions of Gauss law. So see, the first property that you have is, if I give you this sphere with the charge plus q, I have taken a bigger sphere. Let's say the sphere's radius was r. The radius of this is 2r and the charge is plus q. Let's say I have given you a cylinder plus q, or any system with the charge plus q. All these systems are there. What is flux according to Gauss law? Flux is charge divided by epsilon naught. Epsilon naught is a constant that we know, 8.85 into 10 to the power minus 12. Charge is same in all of them. So will the flux be different or same? Will the flux be different or same?
Same.
It will be same, no? It will be q by epsilon naught for this. It will be q by epsilon naught for this, for this, for this as well. So this shows that flux is independent of shape and size. Whatever is the shape and size of the surface, flux is not concerned with it. The surface. Then the second property I have told you already. Second property means whatever charge is outside will not be considered. It means if I have this system, let's say Q1 is there, minus Q2 is there, plus Q3 is there, Q4 is outside, minus Q5 is outside. This is the system that you have. What are the charges that you will be considering? Only the charges that are enclosed. Exactly. So how many charges are there inside, Fatima?
3 charges.
3 charges. So whatever Q enclosed will be, Q enclosed will be Q1 minus Q2 plus Q3. You don't have to consider these charges. So your flux will be Q enclosed means Q1 minus Q2 plus Q3 divided by epsilon naught. This is the value of the flux that you get. So I'll write down the statement as well. Charges outside the closed surface will not contribute to the flux. Now, if you remember, we have done electric field. What is the direction of electric field if you have a positive charge with you? Yes?
Outward.
Outwards, as in away from the charge. All right. Away from the charge. You just have to move outwards. Correct. So similar is the case for flux only. The third property says, if you have an outward flux, as in this is plus Q. So for a positive charge, it will be in this manner. All the electric field will be in this manner. And if it opposite to it will be for the negative charge. If you have minus Q with you, then it will be inwards. So see, if you have outwards flux with you, whenever you are observing that electric field lines are moving away from the system outwards, then you have to consider it as positive flux. This is positive. And if it is inwards flux, then it means you have to consider it negative. This is your negative flux. One more thing is there. If I tell you this is the surface that I have, and all the electric field lines which are enclosed in the system, these are moving just past it. Means electric field lines, these are electric field lines, these are just crossing the surface. So what is the angle that electric field is making with the area vector?
Zero.
Now it will be 90, Fatima. Now it won't be 0. Electric field is crossing the surface area. Electric field is in this manner. If this is your plane surface, electric field is crossing. So do we take the angle of electric field with the plane that you're saying 0? You have to consider the perpendicular. This will be the direction of area vector. Electric field is running parallel to the surface. It is crossing it. So what will be the angle? It will be 90 degrees now. Is it clear, Fatima and rest of you?
Yes, ma'am.
All right. So see, it will be 90 degree. So cos 90 is what? Cos 90 is 0. So that's why you get the flux as 0. Flux is 0. All right. So flux will be 0 now. One more thing. In the starting of the class only, Akifa told us that dipole is what? Dipole is a set of a positive charge and a negative charge with the same magnitude and opposite signs between them. So if I say I have this system with me, plus Q minus Q, this is the dipole that I have. What is the net charge in this?
Neutral.
Neutral. So net charge is, total charge will be
0.
0.
Zero, correct. So what happens? Your Q enclosed will be 0. So therefore your flux becomes 0. Why Q enclosed is 0? Because plus Q minus Q gives you 0. So your flux will be 0. All the points are clear, all the properties. Any doubts in this?
No,
If-
ma'am.
No, ma'am.
All right. If you have any doubt, just ask me. Otherwise, just note down the properties of Gauss law as well. All of you have done?
Yes, ma'am.
Okay. So if anyone is writing, just let me know. Otherwise, let's do very simple questions which have come in your previous year a lot. So you are given a cube and you have the charge in the cube as plus q. This is the charge in the cube. So plus q is there, direction will be simply, this will be the electric flux in this manner. So it says you have to calculate the flux. So this question, I am doing it for you. The next question that I'll be giving will be similar to it. So understand this question first. How do we solve it? First, you have to calculate the flux through the cube, and you have to calculate flux through each phase. So you get many a times these kinds of question where you have different systems with you and you have to calculate charge placed at different positions. So see how you will calculate. For the first part, charge is where you have a system with you. System is cube. Cube is not an open surface. Cube is itself a closed surface. So charge is placed at the center of the cube. So what is the charge enclosed? Charge enclosed within the system means net charge within the system present, and that is plus Q only. So now if you apply Gauss law says what? Electric flux is simply Q divided by epsilon naught. So this will be the total flux through the surface. Total flux through the surface will be Q divided by epsilon naught. This will be through the whole cube. Now see, how many faces does a cube have?
6.
6 faces. So if I tell you, first part is clear to all of you, no? Any doubts in the first part?
No, ma'am.
Yeah, because this is the system that you have. Charge enclosed is Q. So total flux through the cube or the system will be Q by epsilon naught. See, regarding the second part, when I say flux through the cube, this is what? This is Q by epsilon naught. When I say flux through the cube, it means flux through the 6 faces is Q by epsilon naught. No, 6 faces are making that single cube. So flux through the cube will be Q by epsilon naught, and flux through the 6 faces will be Q by epsilon naught. Do I want the flux through the 6 faces? I want the flux through each phase, means through one phase. Just apply unitary method. For 6 phases, you have this value. For one phase, what will it be? For one phase, what will it be? Q by epsilon naught divided by this 6. For one phase, so the total flux through the cube for one phase, it will be Q divided by 6 epsilon naught. Is it clear?
Yes, ma'am.
Through the whole cube, it is Q by epsilon naught. It means through 6 phases, it is Q by epsilon naught. So through one phase, it will be unitary method, Q divided by 6 by epsilon naught. Just note it down. I'm giving you one more question that you all will answer. First, note it down. Fatima, sometimes with the derivation also of Gauss law, these question comes, so that becomes your 5 marker, full-fledged 5 marker. Otherwise, these comes in the 3 markers. These have come in the 3 markers previous. If you look up the previous question, especially this cube question is very common. Even in your entrances. Only Fatima and Krishna have answered. Okay, I'll help you all with this. See, Q is placed at the center of hemisphere. When Q is placed at the center of hemisphere, is it a closed surface? No, Fatima, Zaid, and Krishna all have given the same answer. It won't be Q by epsilon naught. See how it won't be Q by epsilon naught. Q is placed in this hemisphere. This is not a closed surface. This is the open surface that we have. What is the condition for Gauss law? For Gauss law, we need a closed surface. So what we can do, if I put another hemisphere over this, like this, it will become a sphere. 2 hemispheres will join and make up the sphere. Now is charge q placed inside a closed surface?
Yeah.
Yes,
So
ma'am.
it means if you add one more hemisphere, if you add one more hemisphere with you, what will happen? Flux through the sphere will be, what will be the flux through the sphere? Yes?
Q by epsilon naught.
Yes, so all those answers that you all have given, that is flux through the whole sphere. That is not through the hemisphere. So for flux through the whole sphere will be Q by epsilon naught. How many hemispheres are there in a sphere? 2 hemispheres are there. Flux through hemispheres is actually q by epsilon naught. So what all you have answered is flux through 2 hemispheres. But the question has asked you flux through 1 hemisphere. So what will be the answer now?
Q by 2 epsilon naught.
Q by 2 epsilon. This will be q by 2 epsilon. So is it clear how to solve these questions?
Yes, ma'am.
Just note it down. Z, did it get clear now?
Yes, sir.
All right. And rest of you also who didn't answer, Hamza Shekhani, Hiba, Huzefa, just let me, just write yes. I'll know that you have understood. Akshay, what about you, Akifa? So all those who have written, you can now log out. So that's it for today. We'll do some more questions on electric flux in the next class. All right.
Thank you, teacher.
Thank you, ma'am.
All right.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.